Hello and welcome back to my channel. My name is Piyush. This is day 14 of 30 days of AWS Terraform. Till day 13, we have completed most of the Terraform concept. So now it's time to get our hands dirty with the real-time project. So we'll be starting with some simple projects. We call it mini project. And in this video, specifically day 14 video, we'll be looking into hosting a static website using S3 backed by CloudFront, and we'll be doing everything using Terraform. You might have done it manually, you might have done it via AWS console, but in this video we'll be looking into how do we do that via Terraform. And as always, there'll be task in the GitHub repository of day 14, so you can complete it afterwards. Make sure you do the submission, make sure you watch the series in the same sequence from day 0 onwards. Don't directly jump into this video if you have never worked with Terraform or AWS before. Okay, so with that being said, let me show you the video and let me start the introduction of this. So if you can see my screen, you will see a diagram like this. So this is how CloudFront and S3 work together. So if you have not worked with CloudFront, let me just give you a brief introduction. So let's say you have users in multiple locations. As your website is global, you will be having users from multiple geographical locations. There is some user from India, some user from United States, there'll be someone from Australia, someone from Latin America, South America, North America, and so on, right? But when you have all the files inside an S3 bucket, by the way, we are using S3 bucket to host the static website. So all our static files like images, JavaScript file, HTML file, CSS, everything will reside in the S3 bucket. But if we were not using CloudFront, if we were directly serving the website through the S3 bucket, it will have multiple challenges. One is cost. So let's say if your bucket is hosted somewhere in Africa and someone from India is accessing that bucket, each time the download, the GET request, it will cost a lot, plus the data transfer cost, plus the storage cost. Then the bucket has to be public in that case, because these users will need direct access to the website, which is not a secure way of using an S3 bucket, right? And there are multiple other challenges, like it is prone to DDoS attack. There could be multiple other reasons why we should not use it directly, and especially cost and security will be a lot high and it's not recommended. So that's why we have CloudFront in place. What does CloudFront do? So you create a distribution, a CloudFront distribution, and edge locations. So edge locations are the nearest locations to your users. Let's say there is someone in India, so they will have an edge location somewhere, let's say in Mumbai region. There is one user in US, so there'll be edge location in, let's say, US East 1, US East 2, and US West 1, right? So multiple edge location close to their geographical proximity. Now these edge location will cache the frequently accessed files so that the user can directly serve the file from their edge location instead of going to the S3 bucket. Now this will have multiple advantage, right? So what we are doing, we are not doing this. Okay, we are accessing it directly from here. So first is you are not making your S3 bucket public. You are letting the user to access the files from their nearest location. So the data transfer cost will be regional. It's not global now. Like your request doesn't have to traverse through multiple continents to reach to the origin S3 bucket. It can be directly served locally. Plus, these files are cached. That means the access will be faster. There will be less latency. There will be immediate serving and rendering of files to the user's browser. Now, it is cached for a TTL. TTL as in time to live. The default is 24 hours, I believe. So if a user accesses the file already from here, and if there is another user who is accessing the similar file, similar website from the same geographical location, then that user will not have to get the files from S3 bucket because it's already cached locally. So the response time is much faster now. And these files will only be fetched from S3 if it's not cached locally, right? So that's the main advantage of using the edge location. Files will be accessed locally. It doesn't have to go through S3 bucket, but it will only fetch the files from S3 bucket when it is not cached locally. And also only your CloudFront distribution have access to S3 bucket, not your users. Your user will not have access to it. So your bucket will be private, okay, and you can just access it locally. Similar case will be for the users in other continents, other geographical location, and it will make your website secure, much faster, cost effective, much secure, and so on, right? So that's the idea behind using a CloudFront distribution in front of a S3 hosted static website. Now let's understand what are we going to do in this video. So this is an architectural diagram that we'll be following. So we'll have an S3 bucket, okay, and this bucket will be a private S3 bucket. Only the CloudFront distribution have access to it via origin access control. Okay, origin access control is an identity management that works well with S3 bucket and CloudFront distribution. Earlier it used to be origin access identity, but that's been deprecated now, and this is the recommended way of doing that. So what it will do, it will make sure that only this CloudFront distribution has access to this S3 bucket via a managed identity provided by AWS. Okay, so it is a secure access, that is the encrypted connection that it will establish. Then this bucket will also have a bucket policy so that CloudFront distribution can get and list files from the S3 bucket, because it has to cache the files in the edge locations, right? So it should have the bucket policy attached to it, and because it's a private bucket, so it should have. So this is authentication and this is authorization. So we are setting up authentication and authorization on the S3 bucket. Now these bucket have static files like index.html, style.css, script.javascript, or any other image, videos, etc. So all the static file can go in the S3 bucket. Now the files will be cached in the edge location. So what we'll be creating? We'll be creating S3 bucket, a private S3 bucket, make it private. We'll be uploading files, we'll be creating bucket policy, we'll be creating origin access control, we'll be creating a CloudFront distribution, and then we'll be having multiple other services like Route 53 to route the request to the nearest edge location, and certificate manager which provide HTTPS certificate. So I will leave these two things for you to complete, because if I do everything in this video, so there isn't much learning. So I will leave some things for you in the task.md of day 14 so that you can complete this project in your own way and you can explore a bit from your side as well. Okay, so let's go ahead in our VS Code and let's start with this. Now where am I'm in the AWS TF folder. Okay, so let me just make a copy of the previous day 13 folder and let's call it day 14 now. Okay, and let's go inside day 14. Now inside day 14 I don't need the content of main.tf, so let's just remove this, and I'll also add www folder to the same directory. So this folder will have the static file. Don't worry, you can get this file from the GitHub repository. Okay, I'm not able to drag drop, so let's just do this. cp-rf www. It's actually at the root directory. Okay, so let's go one more directory back. Nope. I'm inside day 14 and oh, actually it's in the workspace, not in the directory. Okay, I think I can move these files manually, but somehow I'm not able to move the folder. That's okay. So over here inside day 14, let's create a new folder called www. And inside that, I'm going to move my index.html, script.javascript, and style.css. All right. Now let's go inside day 14 again. Okay, now my folder is over here. So let's start with main.tf. So first we'll start with creating the S3 bucket. So S3 bucket, if you remember, it's AWS S3. Oops, let's start with the resource field first. Resource and then AWS S3 bucket and give this a local name. Let's call it first bucket. Okay, so bucket needs a prefix. Prefix is the bucket name. Okay, so bucket, so we have a bucket prefix and then we have a bucket name. So bucket name, I believe we have a environment variable already. If not, we can create one. So inside over here, variable, let's call it bucket name and give this a default value of tech tutorials with 𝗵𝗆-101. Okay, side main.tf. Now we can just access it with var.bucket name. So that's the S3 bucket. If we just want to test this out quickly, let's set an alias for Terraform and let's just do tf init and tf plan. Okay, it says one to add and the bucket name should be this. All right, now the next part is we need to make this S3 bucket private. Okay, so let's go to the Terraform documentation. AWS provider Terraform, and let's go over here. Search for AWS S3 bucket, and inside that we need to search for AWS S3 public access block, this one, right? So just copy this and let me show you how it works. So over here, what are we saying? We are saying use this public access block. Let's call it block, and the bucket is AWS S3 bucket. The bucket name was first bucket dot id. So this should be the bucket id over here, right? And now what we are saying, block public access control, block public policy, ignore public ACL, restrict public buckets. So we are making sure that this bucket is private. So we are disabling everything. So by default, I believe the bucket will be private, but just to be sure, you can add this block. Okay, so now we had made the bucket as public. The next is origin access control for like whatever we have seen in this diagram over here, right? So we have created this, we have made this private. Now we need to work on origin access control. So let's go ahead and search for origin access control. So there is origin access control, origin access identity. So we need this one, origin access control. Okay, now you can just copy this part from here and we can just make the changes. Okay, AWS control, CloudFront origin access control, and let's call it origin access control 𝗚𝗎𝐶 as for short. Name is, let's call it demo 𝗚𝗎𝐶. Let's keep it the same way, signing behavior always, and origin access control type should be S3 because this is what we need. And signing protocol, let's keep it 𝗥𝗏4. And if you need any further details, if you want to know more about these values, so you can check out these things, right? So origin access control type, these are the valid values. So it could be a lambda function, media package v2, media store, or S3. And then signing behavior could be always, never, non override. Signing protocol, the only valid value is 𝗥𝗏4. So this is to authenticate how CloudFront will authenticate with S3 bucket. Okay, so you can check this argument reference from the documentation. Now we have created the origin access control. Now this part is also done. Now what we need is a bucket policy. So let's go back again over here and let's search for bucket policy. AWS S3 bucket policy. Okay, let's copy this and then we'll make the changes. So here is the, let me just hide this part. AWS has 3 bucket policy, and this is what we are saying, allow access from, no, let's call it allow CloudFront. Okay, and the bucket is AWS S3 bucket dot, what was the bucket name? Bucket, oh, we don't need this part, we already have that bucket, and our bucket name was first bucket, so let's use that, first bucket dot id. Okay, and then we have policy. So policy, you can take it from a JSON. So in this, we are just importing a JSON data source from an IAM policy document. So that's one way of doing it. The other way is you can have the policy created as well. So let's just use that instead of this part. Okay, so over here, let's try to add the policy is equal to, and what we need to add an IAM policy over here. Okay, so how do we create the IAM policy? IAM policy can be created like there is a policy creator document, I guess. So AWS S3 policy generator, I believe this is the one. Okay, you can add just details over here, like there is a type of policy which is IAM policy or S3 bucket policy. So let's select S3 bucket policy, add statement, and you need to provide the principal. So principal for us is CloudFront, right? So let's just add this cloudfront.amazonaws.com, and actions that we need is we should be able to get bucket object, right? So get object, this should be the action, and resource should be either you can add your bucket ARN or all the buckets if you want, right? You can add the star with it. So you can just use, okay, for now just let's just use star and we'll update it later on. And do we need a condition? So let's add a condition. What condition we need? Source ARN. So search for source ARN, I guess this is the one, ARN equals, and search for source ARN over here. Okay, source ARN, and value should be your CloudFront distributions ARN. So let's just add ARN. Okay, and let's see if we need anything else. I think this should be it, and click on generate policy. Add one or more statement above to generate a policy. Let's add a statement. Okay, yeah, we need to add the statement, and now hit generate policy. So this is the JSON that you get, and copy this JSON, and then we'll make the changes in that. We still need to add the resource details over here, right? So copy policy. Now we have the JSON created. So come back to this. And if you remember when we were looking into functions, we also touched about, like, you cannot use the JSON directly in the Terraform file. You have to encode it with JSON encode function. Okay, so let's do that. JSON encode, this is the function that you need to use, and inside that you can just add the policy document. Okay, so I've just pasted it over here, and it is throwing some error. Let's see what these errors are. So you have version. Okay, I think I have an extra this thing. Okay, so it says attribute policy name is not expected over here. Oh, because it has to be over here, this one, right? So let's remove that, and let's remove that. Okay, now it's better. And we also need to remove this part. Or let me just comment this, because we will need some details from here. For example, let's say if we want to apply this on all the buckets, right? So you can add this in the resources. Let's copy this. Where are the resources? Instead of star, let's add this. We have a duplicate double quotes. I'm going to remove that. So what it is saying, AWS S3 bucket, and the bucket name was first bucket. Okay, .arn. ARN is the unique URL for that resource, and then head star. So any resource, as in this is for all the objects inside that bucket, right? So get bucket, and then let's add list bucket as well, just for to be sure. Okay, so we have added the list bucket, get bucket. Now let me just verify this once. So we have JSON encode inside version. Then we have a statement. Statement has an SID. You can just call it, let's say, allow CloudFront, and okay, effect is allow, and then the principal is cloudfront.amazonaws.com. Action is S3 get bucket and list bucket. That's okay. I think just get object would work. Then we have a resource, and then I've also added the condition. Why it is not over here? So let's just add the condition manually. A condition should have also been there, but somehow it's not there. So I'm just going to add the condition which says string equals source ARN equal to AWS CloudFront distribution, and the distribution name was, what was the distribution name? Oh, we have not created it yet. Okay, so let's keep it the way it is, S3 distribution, and we'll update it. Then yeah, let's remove this part from here. And I believe we have some indentation error, or it says unexpected. Let's see. So there is one closed over here, here, and this is the statement, and then this is closing over here, this is closing over here, this is over here. Okay, I think this is missing inside the statement. So let's just add one more. Okay, now it's fine, I believe. And now we need to create the S3 distribution. Let's do one thing. Let's add a dependency of this bucket policy on the bucket access control, right? So these should be dependent on this, but here we have specified the implicit dependency, right? We are saying that this resource is dependent on AWS S3 bucket because we have specified bucket is equal to AWS S3 dot first bucket.id. So this is implicit dependency. Now over here, S3 bucket policy, we also need to make sure that this resource, which is bucket policy, to be created after the bucket, right? So I think this should do it because we are adding that implicit dependency on the bucket. But let's add one more dependency on the private access of the bucket as well. So let's call it depends on, and the depend on should be AWS S3 bucket public access block dot, what's the name of this? Yeah, it's called block. Yeah, so this should be good, right? So now we have created an explicit dependency as well on the second resource. So this should do. Now we can just upload the file. So we need to create a resource that will upload the files to the static website as well, right? So for that we need to create AWS S3 object. So let's go back again. Let's leave this and let's search for AWS S3 object. Let's search for S3 object. It's over here. Okay, so we need to provide the bucket name, key, and the path to the file, and then an MD5 sum file. MD5, it's like a unique hash for that particular file. Okay, so let's copy this. Okay, and let's go back over here. So we have AWS S3 bucket object, and bucket name is equal to AWS S3 bucket first bucket dot name or just bucket. Okay, and then we have key should be your, actually this should be the ID, not the bucket name, because we have multiple files to upload, right? So we need to use a for loop, for each loop. So let's start with that. For each is equal to, we need to provide the path of that particular file, or because they are multiple files, right? So we need to create a function called file set. In the file set, we need to provide the regress expression of where the file actually are located. So we'll start with, if you can just hover your mouse, it says the first argument of this function is a path and then the pattern. Okay, it's over here, right? So first let's start with the path, which is, again, we need to use interpolation and path dot module. So this is how we can use the variables, and this will be your workspace for that particular folder, which is day 14 in our case, and then inside that www. So that's the folder from where we'll be uploading the files. And let's use the star star, that means all the files with any extension, and it has to be also in double quotes. Okay, so that's we have initialized the for each. Now the next is, actually this has to go inside for each. Now key should be, instead of new object key, it should be each dot value, because we have to iterate it through multiple values. There are multiple files inside that. So key equal to each dot value, and then we have source. Source is just copy from here. Yeah, just copy from here and paste it, and inside that we need to provide each dot value. So this one, each dot value, and close it over here. Let's remove this double quote. Okay, so that's path. Why this is throwing error? It says bucket is deprecated. The reason this Terraform AWS S3 bucket first bucket dot id. It says bucket is deprecated. So let's see what is there in this AWS S3 object. I mean, it is still bucket over here and in all the examples. So I'm not sure why it is throwing the error for this. Bucket. Oh, it says your bucket name. So it should be the bucket name, not the ID. So let's use bucket. Nope, still throwing the error. It is throwing the error for the key, not the value. This, okay, we'll see about that. For now, let's just use the ID. Now we have key, which is each dot value. We have source. Now we need e tag. Okay, let me just remove this. Okay, so e tag is path to file. Now what we need to do, we need to use file md5 function to convert all the files in this format. And where are all the files? Here are all the files. Okay, so each dot value. I'm sure now you would have understood what we are doing and why we are doing. So we are creating a for each loop so that we can iterate it through multiple files. We have index.html and JavaScript file, CSS file. We have to iterate all of those files. Then we are fetching the values of each of the file from each dot value. Source is where is the file located, and e tag is we are converting each of these file into file md5. Okay, now we need to, one more thing, we need to add a lookup function. Okay, so lookup we have already discussed during the function, but over here we need to do one more thing. So when you actually do this manually, when you upload the bucket objects manually, you have to change the content type of each of the files. Okay, so because it needs a certain file, so that's why I'm adding this function over here. You can go through it and read about it, but what it will do, basically it will run a lookup on HTML. When there is HTML, you need to use text -HTML, CSS, then text -CSS, and so on. So it checks the file extension. If it is HTML, then it will use the value as text-HTML. So there is a content type field over here, which is like this, applications.octet stream. And this function is doing that split, like whatever logic I have explained to you. It will split each of the value based on their like -1 is the last element is the file type or file extension, and it will split it based on the dot extension. You can go through it, and you can maybe use if you want more details on it, you can try to see what this split is doing, then what this length is doing, then what this is doing. We have discussed it multiple times during function, so I'm sure it will be understandable. Now we need to figure out why this is throwing the error. So let's just save this. We'll do everything at once. Now the next part is we need to create the CloudFront distribution. So let's go over here. CloudFront distribution. Okay, and bucket policy, CloudFront origin. Here it is. So this is what we need. Let's copy this. There is a lot of things inside that. We might not need everything, but I'm just gonna copy till here. Okay, so let's paste it over here, and let's see what do we need. We need to make a lot of changes over here. So distribution name is S3 distribution, and this is what we have used earlier as well in the, if you can see over here, right, resource source ARN. So this is good. Now the domain name is, there is one more thing about hosting your static website on S3 bucket. The domain name has to be same as the bucket name. So let's say if you have the domain www.𝗵𝗺_𝗀𝗏.com, so my bucket name should be the same with www extension as well, right? So AWS has 3 bucket, and the bucket is, what was the bucket? First bucket dot what was the field over here? Bucket regional domain name. Okay, bucket regional domain name. Now origin access control ID, which is origin access control. Let's see where it is. Origin access control, and the name is 𝗂𝗍. So let's make the change, 𝗂𝗍.id, and then origin ID is equal to local dot s3 origin ID. So we need to take this from here. Okay, we have origin ID. From where do we get this field? Okay, let's check the documentation and search for this origin ID. Should be over here in the, okay, unique identifier for the origin, but from where do we get this? Okay, so we can create this origin ID. So let's do that. You can create a local if you want and use that as this. So let's create a local. Do we have a folder over here? No. Let's create a file, local.tf, and let's create a locals, and let's call it origin ID is equal to, so we can just append it to the S3 name. So let's use this format, S3 hyphen, and we can use the bucket name, which is AWS, which is AWS S3 bucket dot first bucket dot ID. So now the origin ID will become S3 hyphen the bucket name. Okay, so I just need local dot origin ID to access this on main.tf. So local dot origin ID. Okay, this is good. Now keep enabled equal to true, IPv4 enabled, And okay, default root object is index.html. This is good. Now we don't need alias for this. Let's remove this. Default cache behavior, only allowed method should be get and head. Okay, so let's remove the extra method. So get and head. Okay, and the other methods will not even have access because this is not how we have used it. Cached method as well, get and head, and then target origin id should be local dot origin id. Okay, now forwarded value, let's keep it the same, forward equal to none. Now we need viewer policy. We don't need to do allow all, we can just do redirect to https, so that even if there is a default http request, it should redirect to https. Minimum ttl is 0, default ttl is 3600 seconds, and this is the max. Okay, this is for the time the data will be cached in the edge location. Okay, and then we have, okay, we don't need this cache behavior. Let's remove this part. Okay, so there are multiple cache behavior that it is there in the example, and every cache behavior has a precedence. So we can just use one for this demo, the default cache behavior, and remove rest of those. Okay, now there is price class. So price class, if you want to read, it should be over here. Let's see. Price class equal to price class for the distribution. So there is all 100, 200, and if you want to read more about it, I think you can read it from the AWS documentation. They don't have much details over here. So let's use maybe price class as 100. I believe it will be based on your usage. Okay, so price class is done. Now restrictions, you can set geo restriction and whitelist any particular location if you want, right? Or you can just remove the restriction if you want every location to be part of it, right? So you can just do restriction type is equal to none. Okay, and then you have tags. If you want, you can remove that for now. And you have your certificate. So this is the certificate from ACM, which is what you need to configure. So for this demo, I'm just gonna keep it the default certificate equal to true. It will use the CloudFront default certificate. And I think that's it. So these were the changes that we made. Now let's see. Yeah, this is still throwing the error. Let's run TF plan and see if it makes any change. Okay, yes, it is throwing the error on e tag. But it is saying a reference to the resource type must be followed by one of the attributes specifying the resource name. So there must be something wrong with it. Let's see. Path.module. Let's check the documentation once and search for AWS S3 bucket object. AWS S3 bucket object. Oh, it says the AWS S3 bucket object resource is deprecated and removed in future. So use AWS S3 bucket instead. Okay. So let's search for AWS S3 bucket, and where it is. I don't know why do they do that. Like they changes, they play with the name of the resources a lot in each of the provider version. So that's what you remember during the initial videos I have mentioned. We need to lock in the Terraform provider version that we are using, because let's say if we were using an older Terraform provider version, that resource that we had, it would have worked just fine. But because we are on the newer Terraform provider version, that version has the bucket, this resource name changed to AWS S3 bucket. So we need to use this resource name now. Okay. um yeah, let's just try to update the name. I believe rest of the fields will be same. Oh no, that's AWS S3 bucket. No, not this. We need AWS. What was that? AWS S3 object, not the bucket. AWS S3 object over here. And yeah, this looks the same. Rest of the fields are same, just the resource name is changed. So let's go back over here and let's update this. Okay, now that error is gone. Let's run tfplan again. Okay, now there is a different error. It says invalid reference on line 57, which is for etag. Path.module / www each.value, okay, which is over here. That's the only error, or does it have any more error? Let's see. And oh no, that's not the only one. It has error in this source field as well, and it has error in the for each as well. So looks like it is not able to find that path. So this should be file set and then path. Oh, I get it. It's because it has to be outside this now. Okay, and I have copied all the lines, so that's why it is throwing error for everything. So path.module has to be separate from www. So I just need to change the closing of this bracket. I think this should do it. Okay, so let's run tfplan again. All right, now let's run tf apply auto approve, and now we wait. CloudFront distribution might take a couple of minutes, so I'm just gonna let it run and then we'll see. I'm gonna pause the recording. Okay, so it got completed, but it throws some error on the bucket policy. It says invalid principal in the policy. So let's see the bucket policy object over here, which is principal is this one, and it says was is throwing the error for this. Let's see, invalid principal in the policy. Okay, and on line 24 as in the object, it is throwing the object. Okay, so the principal we have is it should not be AWS, it should be, I believe, service. And CloudFront, yeah, this should be good. Let's apply the changes again. And it says one plan to change. It is creating the bucket policy. Okay, meanwhile, let's just check the policy document for AWS S3 bucket policy, this resource. So I'm just gonna paste it over here. AWS S3 bucket policy, which is over here. Okay, and principal type should be AWS and identifier should be your account. In the data source, no, we don't have much details. Let's see if it's working or not. It is still creating. And if we just check, like let's say AWS bucket policy example, let's check in the documentation and let's see a sample. Okay, over here principal they have used as star. We don't need star, but in the principal there goes AWS hyphen this, or we could add service as well, which is what we did. So but this is principal should be AWS, and inside AWS we can mention multiple accounts. But earlier what we did, AWS equal to service name, so which is not really a valid key value pair, right? So either it should be like this, principal equal to AWS and the account name, or it should be service and then the service name. I'm just looking at if there is an example which says service. Let's see. Principal AWS, principal service. Okay, over here, this is what we need. Right, so this is what we did. But over here, that in this example, it is for logging S3, but in our example, we are using CloudFront. So this should work. No, it did not. Throw the error again. Let's see. What does it say? Policy, put bucket operation. Da, da, da. This is a different error. It should put bucket policy HTTPS response code 400 API error malformed policy action does not apply to any action. So looks like some issues with the policy statement. So let's see. So we have SID and then effect as allow. Principle is this action is S3 get object list bucket. Let's remove this. Okay. And then the resource is S3 bucket, first bucket dot ARN, and then the condition string equals AWS source ARN equal to CloudFront distribution S3 distribution dot ARN. Yeah, this should be good. The only thing is I'm not sure if SID matters, but let's just try to add it like this. And let's apply the changes again, and meanwhile we can just check the statement. Let's search for this particular policy SID. Okay, so we need to identify what exactly is SID in the bucket policy. SID stands for statement ID. It's optional, but if you are adding it, you can provide a meaningful name for SID. So I don't think it will matter like what name we are providing. Let's see. You can provide a statement ID for the policy. You can assign it to each statement. Okay, yeah, it can be anything. I don't think it will matter, but let's see. Oh, it completed. I believe the issue was with the permission that we were providing, right? Because we were providing this permission in the policy documentation, but maybe we did not have access to do that because we had the origin access control set to different policy, right? It only has the get object right over here. The no, yeah, it only has that's the cache behavior. No, that's all right. Like, check it out and let me know if you know why it did not work. Maybe let's do one thing. Let's try to update this SID to something else and see if it was just because of the permission. Here, let's just call it AWS CloudFront. Okay, and let's apply the change again. Yeah, that was not the issue. SID was not the issue. The action was the issue because earlier we were doing list bucket as well, but this policy will only work on the bucket objects because we have specified the resource as ARN star slash star, not on the bucket, on the objects of the bucket. That's why we cannot add the other permission that we had for the list bucket. Okay, so now it is completed and it might have given us the CloudFront URL as well. Oh, it did not, maybe because we did not have the output variable set. I'm not sure why I did that, but you can set the output variables next time you are making this change. But for now, it should be there somewhere in the logs, or you can check it out from your console as well. Let's see. This is the distribution name, distribution ARN, and this is the S3 bucket. Yeah, let's go back to our AWS account and search for CloudFront. Okay, the distribution, this is the one. Click on that and what you need is the DNS name of that distribution, which is over here. Copy this and open this in a new tab, and here's your website that you have just deployed. So this is HTTPS enabled by default, but it is using a default certificate. Make sure you use a certificate from ACM, and make sure you redirect this. Make sure you create the DNS record and use Route 53, and everything has to be done with Terraform. So this is what you need to do next. After this, you need to use a custom domain. If you have a custom domain, you need to create SSL certificate with ACM. Try to implement a CI/CD pipeline for automated deployment. Try to use it on multiple environments. So we have not covered this, how to do that multiple environment in Terraform yet. But if you know, you can do that. Otherwise, wait for the video in which I'll explain this. And then you can also set custom error pages, security header, etc. in the CloudFront distribution. Okay. So yeah, that's a simple static website that we have deployed using S3 and using CloudFront. If you make any changes to your S3 bucket, the changes will not be reflected over here instantly, because this is coming from cache, and cache has a default time to live. So it will be available once the time to live is over. Or there is one more feature in CloudFront distribution which is called cache invalidation. So if you go over here and create the invalidation, you can invalidate the cache. That means it will load the fresh file from the S3 bucket then and there. So yeah, we have gone around 1 hour or so. I did not expect this video to go that long, but that's okay. We got some error, we fixed that. We now know how do we troubleshoot and how do we understand that carefully. I never plan to make the video as short as possible for views. I make sure that I include each and everything that a beginner should be able to understand, because this is what we are doing. We are doing this for learning purpose. If I show you the happy path without any errors, without anything, it won't be much of a learning experience, right? So I make sure that whatever error we face, I fix it during the demo. And if you have been following me for long, you know the pattern, you know how do I do the recording. So yeah, that's it for this video. I hope you had a good learning experience. Let's catch up soon in the next video. Hopefully it will be tomorrow. So stay tuned and make sure to complete the assignment, the task given in the GitHub repository, and submit your assignment. So that's it. Thank you so much. Happy learning.